everyone, today we're going to be looking at chemical reactions and in particular precipitate reactions. We're going to see whether or not two aqueous solutions will make a precipitate. Then we're going to balance the equations and see what we end up with. So we're going to start today with potassium hydroxide and sodium carbonate. The first step is to see what ions we have. So potassium has a charge of +1. Hydroxide has a charge of -1. That's good because they're both balanced, 1 and 1. Sodium has a charge of +1 and carbonate has a charge of -2. So you can see that these are unbalanced, and because of that what we need to do is have two sodiums, and as you can see up the top there are 2 sodium atoms for every 1 carbonate. So now we're balanced. We have 2 times 1 is 2 and -2. So the next step is to find out what happens when they are actually in solution and they combine. So we look at the cation of the potassium and the anion of the carbonate, and we put them together, and then we do the opposite. So now we're going to look at the sodium in the sodium carbonate and the hydroxide in the potassium hydroxide. So let's check out their charges. Potassium has a charge of +1. Carbonate has a charge of -2. Okay, straight away we should see this has only got 1 to 2, which means we need to put 2 in front of that one, and because of that, that means that potassium carbonate is actually 2 potassiums for every 1 carbonate. Now we've got them balanced. Now let's have a look at sodium. Sodium has a charge of +1. Hydroxide has a charge of -1. Both of them are 1, which means we can just leave them as they are. So now what we need to do is have a look and see, are these charges all balanced? Yes. But is our equation up the top balanced? We've got potassium hydroxide, sodium carbonate, potassium carbonate, and sodium hydroxide. Let's check how many sodiums there are. Well, there's 1 sodium on this side, but when we come over here, there's 2. We can't leave them like this. This means that we've got an unbalanced equation. So what we need to do is we need to put a 2 out in front of the sodium hydroxide, because it's not just a 2 here. That would mean that we would make these charges unbalanced again, because that would make us have 2 plus and 1 minus. So it doesn't work like that. So now we have to go, no, whatever we do to one, we have to do to both. So we have 2 atoms of sodium hydroxide. Sodiums are balanced. Hydroxide now, that means we've got 2 hydroxides. Let's check over this side. 1. So that means we need to put a 2 out in front of this chemical. So now we've got 2 hydroxides, which balances on both sides, but now we have 2 potassiums. So let's check the potassiums on the product side. That's fine. We've got 2 potassiums there already, so we don't have to do anything about that. So what haven't we checked yet? Carbonate. So on this side here, we've got 1 carbonate. So on the reactant side, 1, on the product side, 1. We're all good. We have a balanced equation. But what we haven't decided is whether or not potassium carbonate and or sodium hydroxide form a precipitate. So let's check out solubility rules. So the solubility rules state that most carbonates are insoluble, which means that they form a solid. But then we need to look at the exceptions. except for group 1A carbonates. Well, it just so happens that potassium falls in group 1A. So that means potassium carbonate is in actual fact in solution because it does not form a solid. Now let's have a look at sodium hydroxide. So solubility rules state most hydroxides are insoluble, which means they form a solid, except for group 1A hydroxides. And sodium is in group 1A in the periodic table. So that is also in aqueous solution. So if the question was which one forms a precipitate, neither. So what do we say here? Well, what we need to say is that we have a lot of spectator ions. We have in solution potassium ions, carbonate ions, sodium ions, and hydroxide ions. So when these two solutions were added together, no precipitate formed and all of the ions just stayed in solution. Thank you.